Imagine looking up at a clear blue sky, then later puffy white clouds appear as if by magic. What invisible force is at work transforming that clear air into visible vapor? The fundamental process behind the formation of most clouds is called adiabatic cooling. This simply means that as air rises in the atmosphere, it expands, and this expansion causes it to cool down without losing any heat to its surroundings. As parcels of air ascend, the atmospheric pressure around them decreases. With less pressure pushing on them, the air molecules have more space to spread out and move freely. This expansion requires the air parcel to do work against the surrounding atmosphere. This work uses up some of the internal energy of the air molecules, causing their kinetic energy, and therefore their temperature, to decrease. This cooling effect is called adiabatic cooling because no heat is exchanged with the external environment. If this rising and cooling continues, the air eventually reaches its dew point temperature. At the dew point, the air becomes saturated with water vapor, and any further cooling leads to condensation. The water vapor then changes into tiny liquid water droplets or ice crystals, forming visible clouds. The rate at which unsaturated air cools as it rises is approximately 10 degrees Celsius for every 1,000 meters of ascent, known as the dry adiabatic lapse rate. Once condensation begins, the releases of latent heat from the condensing water vapor slows this cooling rate. You can observe the principles of adiabatic cooling in action in various atmospheric phenomena. For instance, air forced to rise over mountains, a process known as orographic lift, cools adiabatically, leading to cloud formation and often precipitation on the windward side. Once the air descends on the leeward side, it compresses and warms adiabatically, resulting in a drier, warmer air mass known as a fun or Chinook wind, which typically leaves a rain shadow effect. Understanding these dynamics helps us predict local weather patterns and appreciate the role of topography in cloud distribution. A critical concept in this process is the lifting condensation level, or LCL. This is the altitude at which a parcel of air, lifted adiabatically, becomes saturated and condensation begins. It is where the invisible journey of water vapor transforms into visible cloud. Below the LCL, the air is often clear, but once air rises above this level, watch for cloud development. This amazing process of adiabatic cooling is a cornerstone of our planet's hydrological cycle, orchestrating the journey of water from an invisible gas to majestic clouds. By understanding how this cooling mechanism works, we gain deeper insight into the fundamental physics driving weather systems, influencing precipitation, and ultimately sustaining life on Earth. It is a beautiful demonstration of energy transformation in our atmosphere.
If you love learning about water, like, subscribe, and keep exploring with us.